So let's have a look here. Had some problems in class, so I'm just re-recording this. Okay, I handed out a review for the midterm on Monday. And here it is. So let's see, the midterm will basically cover the introduction, types of surveying, okay, what professional land surveyors are and what they do, a bit on surveying units that are used, rounding and significant figures. Now that's something that's come up lately where people have been having a bit of trouble with that perhaps. All right, now the first thing is, as shown right here, you know, if you're doing a level loop, if you've got a benchmark of 100.00, you take a backside of 3.90 on it, you should report that HI as being 103.90 because you shot it to the 100th. So it's important that you have that 0 on it. You would not do it as just 103.9, okay? That's not using enough significant figures. And as I mentioned in class, surveyors take this stuff kind of seriously. So we want that to be 103.90. The other thing we want to be sure that we're doing is rounding, okay? So if you have a number like this, you know, 123.016, if you're writing that out to the 100th of a foot, that should be 123.02. You shouldn't just make it 123.01 because you're not getting that number to its nearest 100th equivalent, which would be 0.02. Anything above at 0.015 and higher should go up to 0.02. So just be sure that you're rounding and also that you're using proper number of significant figures on the numbers, okay? Mistakes versus errors. Mistakes are blunders, things you shouldn't do. Errors are a normal part of surveying where you have things that happen that make your measuring less than perfect. Errors always occur when you're surveying. They can be systematic or random. Systematic are always positive or always negative. They add up or subtract up, I guess you could say. Whereas random errors, some positive, some negative, will tend to kind of even out over time. Systematic errors don't, they accumulate. Okay, precision versus accuracy. You know, that could be maybe illustrated on that assignment that you did with the data that we had about our with our distance measuring. Okay, here's the data that we had for measuring the distance for that point 25A to 25B. You'll see there that everybody got a little something different there. 128.65, 129.20, 128.25, 128.97, 128.27, 128.89, and then 130.50. I can't get the 0 in there right at the moment because I don't have that cell formatted properly. Okay, so what I'm seeing here is all those numbers are pretty close to the actual distance, which I would estimate to be 128.92 because I shot that with the EDM, and that's the best instrument I had out there. But they're varying a bit. So these numbers are not what I would call very precise. Precise means you can repeat your measurements and get the same numbers. Okay, and we're jumping around a good bit here, so this is not very precise, but the average of the numbers was fairly accurate, and all of those readings are fairly accurate. They're all within a foot of what the true value, or what I assume the true value was, which was 128.92. Okay, so I would call that set of readings not very precise, but fairly accurate. Okay, I would contrast that with the GPS readings that we took. Now, I'm sorry we only got 2. I was hoping to get more out there, but it's what we got. So here they are. So we've got northing of 4435, 14.9, and 4435, 14.8. And then we've got these two longitude readings that are pretty much the same, okay? Now, this data is, well, I would call it precise because I'm getting very repeatable measurements. They're coming in very much the same. Little variation there, but not much. However, when you average those values and do what we call an inverse to find the distance, it's 142.92, which is quite a bit off the 128.92 that we assumed that value to actually be, and quite a bit worse than any of these measurements that we taped, okay? So what I would call that GPS data is precise because it looks like it's fairly repeatable, but not accurate, okay? So the taping was not precise, but accurate, or fairly accurate, whereas the GPS was precise, but not accurate, okay? So that's kind of the difference there between precision, which is repeatability, how often you could repeat a measurement and get the same numbers when you redo the measurement, and accuracy, which is how near to the true value you really are. Okay, they're different things. Precision often leads to accuracy, but you need to have a good, accurate instrument to get accuracy. So you can be precise and do your measurements properly with an instrument that isn't particularly accurate, as is the case with this GPS data. Okay. Okay, we did a little bit with trigonometry, a little bit with survey coordinates, geodetic, state plane, and then local. We talked about those. We did some distance measuring the first week, did a lab with that. Then we did some leveling and, took level loop notes and balanced them and did all that type of work, page checks, error closure, acceptable error closure, and did the adjustments. Then we did cross sections and volumes. Okay, we did not do the prismodal formula, so I've scratched that off. But we did cross sections where we reduced the notes and drew up cross sections to scale. And we did volumes, finding the areas and then finding the volumes for different shapes. We also did grade staking. Okay, so that's kind of the stuff that will be on the midterm. So what I would expect to have on there would be some problems. Here's some examples. Here's a level loop problem. Something like that might be on the midterm. Here's a grade problem, and I might add actual grade staking to the test. Here's a reducing cross-section notes problem. Here's a volume problem, okay? And then I have a couple short answer questions too about labs and that sort of thing. So that's the format you should expect for the midterm. Doing some problems that are very similar to your homework problems, and then also answering some short answer questions about kind of the theory of what we were doing and also the things we actually did in the lab, okay? So that's what you could expect. Now, I did want to go over grading just a bit, or grade staking, I should say. So why don't you have a look in your book, as we did in class, and find, I think it's page 548, which has a grade staking example on it of a road. So we have a look at that. So to grade stake, the first thing you do is you find the grade of the line. So on page 548, see if you can find the grade of the line from station 100 to station 300. Okay? And why don't you give that a run and then pause the recording, then we'll get to the answer. Okay. All right, let's have a look at the answer to that. So the grade would be the difference in elevations divided by the horizontal distance. So the difference in elevation is 244 minus 240. And then the distance, so that's the rise basically, because what grade is slope. And then you divide it by the run, which would be 300. That's station 3 plus 0, 0 minus 100. And I should have my 0.00s in there, I suppose. So why don't I get that in there? Okay, so what we're getting here is a rise of 4 feet over a run of 200. So that's a grade of 0.02. Okay, so that grade is 2%. Okay. All right, now the next thing to do there is to find the elevation at station 2+00. So why don't you go ahead and do that next. So use your grade to find the elevation of station 2+00, and you could pause the recording if you're kind of following through this. Or excuse me, I just said the grade, I meant the elevation. The elevation at 2+00, okay? All right, so give that a run. Okay, let's find that elevation here. What we've got is we're going from 200. We started at 100, so we're going 100 feet down the road there. Okay, so that's 200 minus 100. All right. So what you would do then is take your initial elevation, which is 240. And then add the grade times the distance. So that'll be 0.02 times 100. And when you get that, what you're going to come up with is 242. All right. So that's the elevation of the road at station 200. All right, now the next thing to do is to come up with the elevation of the hub at station 200. So use the leveling notes to do that. Okay, so give that a run. All right, so we'll do that. You're at 240.6, and that's the elevation off of the notes. Then you take a back sight of 835. So we got the station, then the back sight, and that is 835. So if you add that to the elevation, what you get is 248.95. All right, then you got a foresight, and on station 200, that's 532. So you'll take the elevation, which actually, I'm sorry, that should say HI there, shouldn't it? There we go, HI. Subtract off the foresight, so you're going to get 243.63. Okay, so that's the elevation on the hub. Okay, now the last thing to do is to find the cutter fill, which is the difference between the curb elevation and the hub. Okay. Okay, so what you've got here is 242. That's the invert elevate or curb elevation, sorry. And then what you do, you take 242 minus 243.63, and you get a cut because it comes out to be a negative number. That means the curb elevation is below the hub by 1.63 feet, so that would be the cut. And then when it's time to write up what we call the lath there, which is the piece of wood that goes next to the grade hub, what you would write on that thing would be first the offset, which is 4 feet over. So a 4 with a circle. All right. And then you're going to, that's how far over you go. Then you write down the cut. So C for cut, 1.63. And then you'll have, oh, you'd probably put some other stuff on there, like to sanitary sewer, station 200 or something like that. So you're telling them to go over 4 feet, cut or go down 1.63 feet to the sanitary sewer, station 200. Okay. So that's what we covered here in class in the first half anyway. So just a little bit of a test review and going over this grade staking a bit.